Hey there, 308. I'm going to go through the quadratic inequality examples. We'll do this in class, but I also thought it would be helpful to have a video to use as a reference. So the first thing I want to talk about are the steps, just really quick. The first step is to get 0 on one side and then factor. This is just like a normal equation, okay? Get all your terms on the left or right side of the inequality symbol, then factor, and then we'll solve in a certain way. So that was the first step. Get 0 on one side, then factor. The second step is to find what we call critical values. Critical values. These are solutions, so we're going to kind of treat the inequality like an equation for a hot second. We're going to get our critical values, and then we're going to actually put these on a number line. So like, let's say for example, we got the answers x equals 2 and x equals 3, whatever. You make a nice pretty number line. These are your critical values, 2 and 3. Now when I make my when I put my critical values down, what you're going to notice is that there's 3 different areas, 1, 2, and 3 of the graph. Okay, so 2 critical values makes 3 different test intervals that we call those test intervals. Okay, so we're going to create these test intervals and we are going to try to find if numbers create positive or negative answers. Okay, so if there is more than one solution in the set, you want to use a U symbol to show a union. What the heck are they talking about there? So this is a separate example. Do you remember back in the day when you would graph something like this? X is less than 2 or x is greater than or equal to 5. Sure, we remember. Cool, guys. So you would make this graph, this number line, and you would have 2 and you would have 5. Now if x is less than 2, okay, you're going to have an open circle on 2 going to the left because it's less than. Greater than or equal to 5 is a closed circle on 5 going to the right because it's greater than. How do I write this in interval notation? Okay, well, take a look. Take a look at this portion right here. Okay, from the left, this is going from negative infinity all the way up until 2. And 2 gets a parenthesis. Okay, well, that's good. But then there's a second part to the graph. The graph also starts here at 5, and then it goes until infinity. So we use this symbol, this U symbol, and then we say, okay, this one starts at 5, it includes 5, and it goes to infinity. So there's 2 parts to the graph here. This U just means or. It means union. Okay? So that's the bottom line. Those are just some extra pieces of information before we start these problems, and now let's get to the problems. First example. All right, here we go. So just like the instructions said, I need to get this equal to 0, so I'm going to subtract over this 8. I end up with a z squared plus 6z plus 8 less than 0. Okay. There's a lot going on here, guys. Starting with the fact that I have to factor. So I'm going to factor this down to z, how about a 4 and a 2? Okay, so plus 4 plus 2. Gorgeous. All right, so now instead of setting each of these less than 0, that's not what we do. I want us to kind of solve this and pretend for a second that we were solving an equation. So what I just do is z plus 4 equals 0, and z plus 2 equals 0. And I get 2 answers, z equals -4, z equals -2. These are not the solutions. These are your test intervals, your critical values. Those are your critical values. So let's make our number line with our critical values. So The smaller number is -4. That always goes first. The bigger number is -2. Okay, and again, I have 1, 2, 3 different intervals that I need to test. What do I mean by test? I mean that I want my answer, okay, this is key, to be less than 0. So I need to find the interval where your solution, or where it is less than 0. Okay. So here's what we got to do. I like to take this part right here, the z plus 4, the z plus 2, and I like to kind of write those down here. Z plus 4, z plus 2, because this is my original equation. And now I'm going to test these intervals. I'm going to pick a test value. So for example, something over here, maybe -5. Okay, I actually don't draw it in, but I'm just showing you that I'm picking a value over here. So try -5. Plug it in. -5 plus 4. That's -1. I don't even care what it is. I just care if it's negative or positive. So for z plus 4, it's negative. Okay? -5 plus 2, same value plus 2, that's my test value, okay, is -3, so that's also negative. Now look, I am taking the product of these, okay? So negative times negative actually gives me a positive product. So the product of this is positive. Do the same thing with your second interval. So I'm going to pick a test point in between -4 and -2. How about -3? Okay, so for my first one, -3 plus 4 is +1. So it's positive. Okay, -3 plus 2 is -1. So I'm taking the product. Positive times negative is negative. So this one's negative. I hope this is making sense. Last one, z plus 4. Let's pick a bigger number than -2. How about 0? So 0 plus 4 is 4. That's positive. 0 plus 2, also positive. Positive times positive is positive. So this interval is positive. Okay, well, what did I say over here in yellow? I said that I want to find the interval that is less than 0. There's only one place that's less than 0, and it's right here. This is not underlined. It is less than, so I have open circles. That orange section of the graph that I just colored in, that, ladies and gentlemen, that's your solution. Whoa, don't move that. So your final answer in interval notation is -4 to -2, because that's where my graph is less than 0. Let's do another one. That was intense. Okay, same idea, guys. Same idea. Let's get that 12 over to the left-hand side. We have an r squared plus an r minus a 12 is greater than or equal to 0. Okay, so let's just make a side note right away that this time we want to find the intervals that are greater than 0. Technically greater than or equal to, which means I'm looking for the positive intervals. Cool. All right, factor that out. We get r plus 4 and r minus 3 greater than equal to 0. Okay, and now we find our critical values. We have critical values of -4 and +3. Okay. So those are not necessarily our solution. They're just points on the graph that we care about. So we have a -4 and we have a 3. We have 3 test intervals. So I'm going to write down the first factor, r plus 4, and then r minus 3 for my testing. And by the way, guys, I do this part in my head normally. I'm just trying to show the work for your notes. So I'm going to pick a number less than -4. How about -5? Plug it in, -5. plus 4 is a negative 1, so I get negative solutions. Now for my second factor, r minus 3, I get a negative 5 minus 3, negative 8. That's a negative answer. And then for my actual interval, we're taking the product, so negative times negative is positive. So this interval is positive. Middle guy, we got, how about 0? So 0 plus 4 is positive, 0 minus 3 is negative, positive times negative is in fact negative. And finally, we have bigger number than 3, so how about 5? 5 plus 4 is a positive 9, 5 minus 3 is positive 2, positive, positive is positive. Okay, so the hardest part's over. Now I just have to figure out, what are they asking? They want numbers greater than or equal to 0. So that's where the intervals are positive. That is happening, and since it's underlined, we can shade in the circle. That's happening here. That's also happening greater than 3. Okay, so this is a union problem. My intervals start from the left, right? So start down here, go all the way to negative 4. So all the way to the left is negative infinity to negative 4. We got a parenthesis and a bracket. And that's in union, okay, with 3 to infinity. Bracket on the 3. Parenthesis on the infinity. And that is it. That's your answer. Ta-da! Next one. This one's not bad. It's not bad because it's already factored for you. So don't try to pull any foil on this one, because you'll just get back to something ugly that you have to refactor anyway. Instead, you can just find your critical values right away. So this time, your critical values are going to be y equals negative 2, y equals 7, y equals negative 12, and we can go right to our number line. Now, make sure that you put these numbers in ascending order, meaning the smallest number first. That's a negative 12. Then it's negative 2. Then it's 7. So instead of 3 testing intervals, we have 1, 2, 3, 4 testing intervals. So that's nothing we can't handle. I know you guys got this. Let's go. I'm going to write out our factors here. We have a y plus 2, we have a y minus 7, and we have a y plus 12. Again, you don't have to do this every time. You can just do this in your head if you prefer. So I'm going to pick a number over here, smaller than negative 12. How about negative 15? Okay, negative 15 plus 2 is negative. I don't care what it is. We just care about positive, negative. Negative 15 minus 7, also negative. Negative 15 and 12, that's negative 3. Okay, we're taking the product, right? This times this times this. So product, this times this, negative times negative is positive. Times another negative becomes negative again. So this interval is negative. Okay, let's do our second interval. Let's pick a number here. So how about, I don't know, negative 5. Negative 5 plus 2, negative. Negative 5 minus 7, negative. Negative 5 plus 12 is positive. Now multiply. Negative times negative is positive times positive is positive. Cool. Next one. We have to pick a number here. My favorite number, 0. So 0 plus 2, positive. 0 minus 7, negative. 0 plus 12, positive. Positive times negative is negative times positive is negative. And last but not least, guys, we have to pick a number over here. How about 10? That was my phone. I'll put it away. 10 plus 2 is positive 12. 10 minus 7 is positive. 10 plus 12 is positive. Positive times positive times positive is positive. What do we want? Good question. We want greater than or equal to 0. So that means that we are looking for our positive intervals. I'm going to zoom out a little. So again, this means we want the intervals that are positive, that are greater than or equal to 0, which is meaning positive. So the ones we want, okay, are these two, the ones with a plus. This is underlined, so we do filled in circles. To write this first interval, I have a bracket, -12 to 2, -2, in union with 7 all the way going out to infinity. That 7 gets a bracket to infinity, parenthesis. And that is it, guys. That's how it's done. That's the answer. All right, I hope this was eye-opening and worthwhile. We'll talk about it tomorrow. Peace out.